So let's get started. So my name is Shimon Tolts. I work at Ironsource, this office here. And I'm the general manager of the Data Solutions Department. And I'll tell you a little bit about a system that does all the processing of the data for us. So Ironsource has 800 employees, and more than 400 of them are developers. And right when we started, we had different departments within the company doing different things in terms of ed tech. So, Renee? I'm sorry, 1 minute. Nicole? Yeah, great. So, sorry about that. Yeah. They're making the Halloween preparation, you know. So, we have many different departments. And I joined in 4 years ago to lead the infrastructure division that would do cross-department tools. So instead of every department building the same thing over and over again, we would identify infrastructure bottlenecks where we can leverage building one system for everyone. And of course, data was one of them, because we would have the mobile division, the desktop division, the video division. They all do different things, but at the end of the day, they all want to track data. So this is a graph just showing you the challenges that we had to face. We had hyper growth, and we actually scaled to more than 200 billion events processed today. An event is every time someone sees an ad, clicks an ad, does any interaction with it. So we needed a system in order to collect, process, and store all of this data in order to do billing, of course, which is very important. And then to give our BI analysts the abilities to look into the data and to actually drive insights out of it. So in order to do this, we built this system. And the system has several components. So the first one is the SDKs, obviously. So we have, I'll call it a developer democracy, where anyone can use any programming language and do basically whatever they see fit, as long as it makes sense for the business, right? So we have many different SDKs that you can use in order to send your data, which is just sending JSON key value pairs. Then we have our collection layer. So once you send the data from the SDK, you have our first tier layer receiving it. And that's our collection layer that is spread across 13 regions of Amazon Web Services. So we leverage Route 53 latency-based routing in order to route the event to the closest region. Or should I say to the lowest latency. By the way, feel free if you have any questions. You know, it's an open talk. Don't limit yourself. So that's the first area that's the first checkpoint where the data is received by our system. And then we store it in S3, the raw format as we received it. Then we transport the data into our processing layer, which is backed by Kinesis. And that's I would call it the logic layer, right? Where you want to do IP to country, breakdown of user agent, and any enrichment before you want to insert the data into the data warehouse. And this is very powerful because most of the times, the event that you receive has a lot of metadata around it. The user agent, the IP, or you want to prepare it in order to stream it into the data warehouse. Everyone's alive. So you can do mapping of different fields. You can do currency conversion. And basically, it's just Python code that you can submit and do basically whatever you want. Don't do Bitcoin mining. We'll catch you. But, you know, in a general sense. And then after...
Is that on streams or Firefox?
So no, that's streams. Yeah, it's a different talk, but we take everything, we use protobuf, shove it into streams, and then we use spot instances in order to read it from the stream. That's how we get our system to be cost effective. And then after we finish processing the data, we ship it into S3 and insert it into Redshift or Google Cloud and BigQuery or Elasticsearch or Aurora or Postgres or whatever the data target that you would want to use. An illustration of the process. And that's part of our architecture. So again, it's not the talk. The talk will focus more about like this part and what we have learned and why do we use actually serverless architecture. So what am I trying to show here is that we have different microservices, and each microservice is responsible of doing different things. So we are heavily backed by Docker. And when you start ramping up with services, you have 1, 5, 10, 15, 20, and so on. It's very nice, but it gets a little bit difficult to orchestrate all of that and to have a centralized config area, right? Because you need a fleet management that will tell all the microservices what to do and will control them. So a little bit about how we work and how we're constantly able to iterate, because I think that it's very important to also understand the philosophy and the way that we work. So everything is a microservice. So about a year ago, we transformed everything into Docker containers. Everything we build has a Git repository, README file, and a Docker file. Everything. And it's really, really powerful. And then all the services are communicating with each other using REST APIs, streams, queues, different ways of communicating. And we mainly run Node.js. We have some Python and some Go code. As I said, Docker. I don't need to sell you on Docker. I guess that everyone loves Docker. And we are also heavily based on Amazon Web Services. And this is like the way we work is that we have dev teams, and we don't have R&D that is split into different roles. We don't have QA, IT, DevOps, and so on. We just have software developers, and they do everything. We do everything, right? So we write the code, we configure the Linux server, the auto-scaling group, and we wake up in 5 in the morning if we have bugs. So we try to use managed services as much as we can because we don't want to wake up in 5 in the morning. So I'll show you today how we use DynamoDB and RDS together with Lambda and API Gateway. And everything is running as part of a CI/CD stack. So for every commit we do, we run our unit test, end-to-end test, deployment using Jenkins, CodeFresh, and Git. So that was the overview, okay? Just to give a sense of like how our department works. And now to deep dive deeper into the microservices themselves. So for some reason, it's cutting out, but okay. It worked, but it's the wrong thing. Hold on. So if you think about it, basically serverless. So we had the servers, which used to be the cats and the dogs, right? The pets versus the cattle. Then we have the different servers, which is like the cattle, right? So you spin them up, spin them down, auto-scaling groups. I don't even know how many servers we have because they constantly changed according to traffic. And Werner Vogels, the CTO of Amazon, said that the next big thing is the horde, which is like Lambda, the serverless architecture. Because what is it? I don't know. It's a server. It's not a server. It's serverless, but it has a server at the end, right? And this is how our system looks like in general. So each one of those is a representation of a microservice. And each one of them does something else. Very, very good, very, very specific, but does something else. And in order to share all of the configuration and the state between the different systems, for example, you have a user that's registered or signed in, or it requested to perform a certain change in the system that involves 4 different microservices. So this is the way we do it. So every microservice talks to API Gateway, which is a service that is basically receiving HTTP requests, and then you can map it into your server or into a Lambda function. So we use Lambda. And then we have different Lambdas for different routes and for different use cases. So we might have one Lambda for several routes, or we might have one Lambda per route. And Lambda is basically, we use Node.js. It's just Node.js code that does something. And this part here is really stateless. So in order to keep the state, we leverage three things. We leverage RDS. We use Aurora for that. We leverage DynamoDB for key value stores. And we use Elastic Cache for Redis if we want to do things that are cached. And this is just a simple screenshot. So this is one of our serverless API gateway methods. You can see we have all the different types, account, clusters. This is just stuff for us, right? Which Redshift clusters do you have, or things like that. And it's very, very nice because you can see it very nice. And once there is a request, we do authentication or don't do authentication if it's within. Then we run a certain Lambda function. That's the Lambda function that we run. And then there is a specific pattern that happens here. And you can think to yourself, okay, why are we doing this? Why aren't we just having another microservice, call it the config microservice, and just run it? So I would use serverless for everything I can if it makes sense. The only problem here is that, in my opinion, it's not scalable in terms of requests. We process more than 200 billion events every month. Okay? If we would have paid for API gateway for every one of those events, we wouldn't have this nice office. We would have some basement somewhere, because it's very nice for low amounts of traffic, in my opinion, but it's not good at all for large amounts of traffic. I'll give you another example. You could say, why don't I do my data pipeline using serverless and Lambda? You could use Lambda for every event that transforms and continue. But Lambda costs twice as EC2 on demand. And we use pod instances, which cost 10% of on demand. So the price difference is so high, and our pipeline costs hundreds of thousands of dollars every month as it is. So every little bit of a tweak that we can do is very, very significant to us. So we use serverless where we can, where we don't have so much requests. But it's still nice traffic, right? So that's the last 24 hours. We have 1.8 gigabyte and 254 lambdas. That's a very nice Amazon bug. I'm sure everyone knows it. And they don't fix it for so long. If only I knew someone from Amazon. So we have 5.0 E7 invocations, but it really runs. So I think this means it's like 10,000 invocation, and that's like 2,500 invocations. So every time our services are pulling data, and they're constantly being updated through those serverless procedures. And now I want to talk a little bit deeper into like actually how we do it, right? So when you start, you see the concept of Lambda and you're amazed. You go, that's so great. You go, you start pasting your code into the editor, and you start running the Lambda function, and it's really nice. But when you have 200 Lambda functions, it's not nice at all, and it's unmaintainable. It's nice for a patch, right? But it's not. We are counting money with this system. Like literally, my salary goes through this system. So we don't want to fuck up. So it's very important. So the next level, this is like what happened to us and many of my friends. So you start by pasting the code. Then you say, okay, I want to use external resources. Maybe I have different packages, or I want to use Git. Simple thing, very important, but you don't have it if you just paste it. So then you say, okay, I'll have my code in Git, and then I'll build my deployment script, right? How hard can it be? How many lines is this? I don't know, 15 lines? So you just remove the zip everything, and update your Lambda function with the configuration. So again, it's really nice when you have 1, 2, 5, but it's not really scalable. And the most common problem that I see when I meet people who start with serverless and then they go like, oh my God, this is crazy. I don't know what's going on with my system. Don't forget its code. It's very easy to start pasting in stuff and just using it, but treat it as actual code and treat it as your server. It's like today we have Docker containers, right? So we're building the code and we're writing the code, building the container, and shipping it into Docker Hub. think of it the same way. So you use Git, you use versioning, you do packaging, you have CI/CD automation for your Lambda functions. It's very, very important. And you have automation that actually tests everything. And the very nice thing is that it's very easy to set up new functions and remove them. It's a lot easier than configuring servers. So actually, every time we run our automation, we just build the whole stack and destroy it. And it's really easy, really fast, and it works really great. But my advice to you is not to try to do it yourself and to start using the great development tools that the community has, like TJ's Apex or the serverless framework, because it's really structuring everything. So a little bit about those. So those are frameworks that are used in order to go production live with the serverless code. Apex is a more lightweight one. It just packages everything nicely, versioning, and uploads it and updates your Lambdas. Serverless is more of an actual framework. It creates cloud formation stacks that go and configure all of your different Lambdas and systems. I think that this is a bit of an overkill for us. At this point, we just use Apex. But it's very, very important to not look at it, to take it very seriously, because otherwise it's not scalable and you're not going to leverage this system. So that's a little bit about how we use the serverless architecture in our production system. If you have any questions. Thank you very much. So, yep.
Can you talk a little bit about how you do your deployments when you change your Lambda scripts and you want to update?
Yeah, so what we do is we use Apex and we do a new version for every Lambda iteration. And then we have a separate API gateway for production, staging, and dev. And they are routed into different Lambda functions. And then we just update the Lambda functions with the latest version. So we would go, update the dev, run our automation, update staging, run the automation, and then update production. And this way you can also do rollbacks because you have different versions. And it's not just code in your editor and you're trying to do Command Z, and it's not working, right? That's how we do. Yep.
Okay, you were mentioning how you had all these microservices and you were managing them using the Lambdas. Can you talk about what the Lambdas actually do and how you manage?
Okay, so those are different services, and maybe that's the more interesting part. So we need to pull a lot of configuration, right? We manage hundreds of Redshift clusters, and we have lots of customers and streams of data. So when a user signs up to our system, it actually goes and updates his information and registers him through the serverless architecture. So it would go to cluster, and it would use a put event or go to accounts and update his information. And then every minute, our backend servers that process the data would fetch the new data and would have all of the accounts updated. So for example, if you just send data to our system, we will discard it. You won't be able to send the data. But if you register and you receive an API key, then the servers will be open. And we will accept your traffic. But we don't want to deploy new code every time a new user signs in, right? So we use this state sharing configuration where we would update the DynamoDB tables with the API keys. And our microservices will pull the different configurations and store it in memory. And then every time they would check if there's a new version, new revision, they will update it or continue.